And welcome everybody. We have an exciting workshop planned for you. It's Codeword Decarbonize. As you know, these workshops are eligible for AIA credits, and therefore I am showing you this screen and pointing out that indeed this is an AIA session for continuing professional education credits. Nothing in here should be construed as an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or products. And I am showing you the appropriate copyright notice. Our agenda for today is fairly straightforward. We're going to have a moment of introduction with our exciting panel members. We're going to go into rapid breakout rooms. These will be quick, no more than 15 minutes, just to get the juices flowing. And then we'll come back for the remainder of our time to have a fun and exciting conversation. Now, I am personally really excited about this conversation. We've seen where codes have come up, and I think we have the opportunity today to discover something important together. Right. So we've had a few previous workshops. We had our kickoff, then we had a workshop on reducing loads, a workshop on beyond the boilers, on domestic hot water systems, on steam, on microgrids and hydrogen. And in these workshops, we talked about and identified some technologies that might be helpful for decarbonizing. We talked about how we may overcome barriers to get these type of technologies implemented. And in some instances, you may have thought, or perhaps even said, but the codes don't allow that, or the codes make it too difficult. So today, we want to talk about the codes. And yes, we wanted to look at the specific items in the code that might be perceived to make decarbonization more difficult. But we also want to look at how the codes might promote decarbonization. We're looking at this from both vantage points. And so in some senses, my bias is, and my hope is that we consider the larger question. Maybe I should put it this way. The National Academy right now is saying, and is about to say louder and more forcefully, that we need to reduce greenhouse gas emissions in healthcare by 50% by 2030. If I have this right, California is saying we want to get 40% below 1990 levels by 2030. The Biden administration just committed to 50% by 2030. So it's clear that we have a journey to go on. And so the question maybe I'm really interested in is, if we need to reduce by 50% by 2030, how can we get there? And how can the codes be an integral part of that journey? In some senses, right, we're looking at both the high level question and the specific question today. And so the format is very, very easy. We'll do this quick introduction. As I mentioned, we'll jump into breakout rooms. You'll have a choice of 5 breakout rooms centered around specific codes that we've highlighted today. So there's a breakout room around OSHPD, around Title 24 requirements, the CEC code, around ASHRAE 170, around ASHRAE 90.1, and around FGI. We'll get into those rooms, ask a couple of key quick questions, and then we'll come back to hear and discover how these might play together in an ecosystem that can help decarbonize our healthcare systems. And so with that said, I'm going to jump into introductions. I'll stop sharing my screen. Right. And I'm going to introduce our panelists here. I'm just going to say their name, and I'm going to ask them to introduce themselves. And then I have a question that I'd like them to take about 30 seconds to ask. I'm asking them to give kind of a conceptual answer here. And so the question is simply this. We need to be headed towards a 50% reduction by 2030. What role can we imagine the codes playing in that journey. I will also say that some of our panelists are here because they serve or have served on particular code panels. They are not necessarily speaking on behalf of that code panel. They are speaking on their own behalf. And I also want to say that we are gathered here in this community is gathered to go on a journey together, right? To journey towards this decarbonization effort. And so we are understanding where we are today, and we are hoping that we can create a better future together. First, by in this series of workshops, discovering together the ways we might do that. And then in the future, coming together to create this guidebook and socialize it so that the entire community has the opportunity to do this. Okay, with that said, let's jump into introductions. So first, I'd like to introduce Dave Mason. Dave, can you give some quick details about yourself, and then answer that? How do you see the code helping our journey?
Hey, yeah, hello everybody. Yeah, my name's Dave Mason. I'm a senior mechanical engineer at Oshpod. I'm the technical lead for the mechanical engineers there, and I'm on the building standards unit. So I draft amendments to the mechanical and plumbing code. And I'm also on the ASHRAE 170 technical committee, non-voting member so far. So I'm really glad to see a couple of my colleagues from there here. And, you know, in general, just real quick, as far as how the codes affect trying to decarb, vast majority of technologies I've seen proposed and that I've thought could be used aren't really hindered by what we see in the mechanical and plumbing codes. But the 300-pound gorilla in the room is all the energy spent on reheat due to the high ventilation rates that are required. So I look forward to contributing to that discussion moving forward from where I sit. I've got some good background in that. So that's kind of the biggie, really. And a lot of us know that. So there's my introduction. Look forward to talking to you.
Great, thank you, Dave. And then Bill Gao.
Yeah, hi, I'm Bill Gao. I also work with Dave at Oshpod. I'm a senior electrical engineer. You know, this 50% reduction by 2030 is a pretty big goal for healthcare. And I would really like it if the federal government helped us out by not adopting old codes. And I know Walt and I have discussed this before. We could do a lot at the state level, but as long as the federal government says you have to build a essential electrical system for a hospital based on 2010 code, I'm in a hard place. And so I'd love to see movement at the federal level where these directions are coming from to allow healthcare to actually use new technology to replace diesel generators. And I know Walt and I have worked together to get the provisions in the code so that we could actually do this in the future. We just need the federal government to step up to the plate and deliver for us at CMS in particular, which is, that's all I got, Troy. I guess I'll get off my soapbox.
Perfect, thank you, excellent, Bill. Next we have Jeremy Barber. Please go ahead and tell us your affiliation, and then tell us what role you see the codes playing in helping our decarb journey.
Thank you, Troy. My name is Jeremy Faber. I am a voting member of ASHRAE Standard Committee 170. I am also a mechanical engineer for a consulting firm out of Ohio. And the role I would see with codes is one, being open to new innovations, as well as those code groups looking to new research that maybe allow different approaches that aren't currently allowed, if there's research that supports a change, and really just relying on new innovations that can come about over the coming years.
Excellent, thank you, Jeremy. Next we have Michael Sheeran.
Hi, good morning. My name is Michael Sheeran. I'm the CEO at TLC Engineering Solutions, headquartered in Orlando, Florida. And I'm also the chair of ASHRAE Standard 170, which is ventilation of healthcare facilities. Speaking just from the perspective of someone that deals with designs and deals with the codes in regards to ventilation for healthcare facilities, certainly what Dave Mason highlighted in regards to reheat is an easy target, if you will. There are better ways or free even ways of accomplishing what reheat is. I think it's important that we, and as any of those folks that deal with 170 know, we struggle mightily with what are appropriate levels of ventilation, outdoor air and total air moving through a space. And quite frankly, the perspective of a pandemic is a little hard to embrace significant change to that. But it is also a reminder as to where those things may be important and where those things may be less important. And maybe it's a matter sometimes of prioritizing where are those spaces and places. There are things like natural ventilation that I think are an easy target also for certain environments and times a year in places as well. But otherwise, I welcome the conversation.
Excellent. Thank you, Michael. Next we have Tim Peglow. Tim, go ahead and give us your affiliation and then answer the question, how can the codes play a significant role in getting to our decarbonization goals?
Thank you, Troy, and thank you for all those that are attending. I'm looking forward to this as a learning experience for a couple of reasons. One, I'm part of the ASHRAE Decarb Task Force, so how do I get ideas that will help exactly answer the question you're proposing, Troy, is supporting decarbonization. During the day, I work for MD Anderson Cancer Center. As people can understand, we have probably the largest group of immunocompromised patients in the world in our facilities that I manage. So that creates a significant mental challenge, so to speak, is how do I create an environment that is safe and free from any contaminants or illnesses that would affect our patients quite easily. A little bit of background, a little bit of trivia. I've been on ASHRAE 90.1 for I think about 13 or 14 years. And you guys referenced heat recovery chillers. I took the lead on that addendum last time to get that into the code. I think one of the challenges we're going to have, and I was just on a call this morning, is where the codes are in their cycle. So I was on a call this morning for ICC codes for 2024, which are in the hearing process. And I know even on 90.1, we're still working on the 21 version. We're halfway through. So if we don't start getting things in the code cycle for adjustment in the next probably 6 months, it's probably not going to make the 22 version of the code. So there's some timelines in front of us that are also challenges, but I'm very excited to hear perspectives that I can begin to share both at 90.1 and on the ASHRAE Task Force on Decarb. Thanks.
Tim, thanks so much. Those first panelists in some senses represent, i.e. they are currently or have been on a particular panel. Now we're going to hear from our other panelists, some of whom have also been on a particular panel, but who are representing viewpoints that we think are really important in our decarbonization efforts. And so next I have the honor of introducing Kara Brooks. Kara, take it away.
Thanks, Troy. My name is Kara Brooks, and I manage the sustainability work for ASHRAE. I'm really excited to be here today and hear this discussion. I would say that the biggest challenge that we see, and I'm just going to echo what Bill said earlier, has to do with the fact that we're really bound by the CMS conditions of participation. We really support new technologies and going with the decarbonization technologies, and our advocacy team is always out there working toward new technologies and unifying codes. However, we're really bound to the old codes. And so we're always encouraging that those codes get updated and so we can look at some of the newer technologies.
Excellent. Thank you, Kara. Next, we have Bing Liu.
Thank you, Troy. My name is Bing Liu from Pacific Northwest National Laboratory. I'm a senior strategic advisor, particularly focused on building decarbonization, electrification, and the building to grid intersection to support U.S. Department of Energy and the Biden administration on the building decarbonization. I'm also a voting member of ASHRAE's newly formed task force on building decarbonization. The task force just formed a few months ago, really try to mimic their new business model ASHRAE is creating through their academic task force, being nimble, moving really fast, identify the key issues to address, and provide technical resources, guidance to the membership, global membership of ASHRAE on the building decarbonization. My role at the task force is I'm actually particularly leading a working group on the building performance standards. You know, in order to really move the needle on building decarbonizations, building energy codes play a key role. They are much more impactful on the new construction and major renovations. However, the most of their emissions is coming from existing building. Even by the year 2050, 70% of building stock is still existing building. So the building performance standards, it's particularly looking for a way to address the decarbonization for existing buildings we have today. So that's another big piece of areas. I'm not sure it's part of scope of this working group, but it is one of the main scope from the ASHRAE's perspective on this task force. My background is also, I've been working on the building energy codes, leading the codes program, support DOE about for 16 years before I moved into the new role. So I was the member of ASHRAE standard 100, 189.1, and 90.1, and also heavily involved with IECC codes development as well. We heard a lot of codes could be barrier, but also codes can be motivator. One thing I see the codes, particularly for progressive codes, like California or Washington codes, I gave you example is the codes can be innovative. You know, in Washington state, we just passed the codes. Now the new codes, commercial codes in place, we actually starting to regulate HVAC system efficiency. We don't care what kind of system you design, but we're really looking directly from carbon point of views, your design system efficiency have to be better than the baseline, which is a market system efficiency, directly looking using the carbon as a metric. So this is really a great opportunity to build in the demand from the cost perspective to build in the demand of the market. So if we have this kind of demand, it's really help to inspire the motivations from the supply chain all the way down to the end use. So I do say the codes play a key role to directly address the decarb, including the healthcare areas.
Perfect. Thank you, Bing. And last but not least, David Eldridge. David?
Hi. So I'm a member of the ASHRAE TC 9.6 for healthcare facilities, and I'm the chair of the energy subcommittee there. So we've, definitely been interested in similar topics to this, and working on some other guidance that I think would be very complementary, as it turns out. I'm hopeful to be able to take back from this, some ideas that the TC can help develop research, that's needed to help support design teams in the future. I'm also on TC 7.6, which is building energy performance, and I think that's a good crossover to this group as well. I know a lot of the focus is on, hey, let's build efficient new buildings, but I'm also very interested in bringing the energy use of the existing buildings down as well. And pertaining to the topic, hopefully code-wise we can look at, in addition to prescriptive options and increasing the stringency of codes to bring the energy use down, outcome-based paths as well, so that we can leave the design teams with flexibility on how they can address the measures. I know it was mentioned earlier from the other speakers about reheat, so that's obviously the biggest end use that we want to target for a reduction, but you know, the eventual solution will probably have to address, you know, all the end uses, and so we need to be flexible on how we can reduce those each a little bit to get to that goal.
Great. Thank you very much, David. All right, so we are about to go into breakout rooms. And so what that means, as I give a little bit of time for Jess to finalize the rooms, is that if you haven't sent Jess or everyone what breakout room you'd like to go in, then you will be assigned. At this point, we are actually going to combine the CEC or the Title 24 room and the Oshpod room. So we'll have a California room, which will be fairly exciting. And also, I want to highlight that there's somebody else on the call. I wanted to highlight them earlier, but I'm going to highlight them now. I'm hoping I'm not putting them on the spot. If I am, forgive me, but I want to highlight that Brittany Moser is here. Brittany, if you are willing, and if Jess can help get you off mute, would you be willing to introduce yourself quickly as we go into our breakout rooms?
Sure. Hi, my name is Brittany Carl Moser. I work at Affiliated Engineers as part of their building performance practice team. And I'm on ASHRAE Standard 189.3, which is Sustainable Building Design for Healthcare. And I also participate in 189.1 meetings, and I'm a voting member on 227, which is for the passive building design. So looking at all of those, I know that we've already covered a lot here about reducing reheat in the buildings that we don't have a lot of passive availability for, but also being able to look at where we can have passive design in buildings and spaces in those buildings where it makes sense, and making sure that that standard also aligns with 90.1 and 189.1, taking from them what makes sense, and building new language where that also makes more sense for improving. And resilience is also something that we're starting to look into for 189.1, and I know a lot of other standards as well. So trying to figure out how resilience and decarbonization can be looked at together. And that's all I have from here.
Great. Brittany, thank you so much. And you highlight something really important. As we go into our breakout rooms, we're going to look at those specific codes, right? We're gonna jump right in. It's meant to be rapid. It's meant to fire your system one thinking. So we're going to go quick. You'll enjoy it. Just dive right in there. We're gonna answer 3 questions. Number 1, what changes to this code might help support decarbonization? And then question 2, what aspects of this code are right now perhaps restricting decarbonization efforts? If there are aspects that are restricting decarbonization efforts, we want to understand how it's restricting. We want to understand what the purpose of that being in the code is. And then we want to understand if there's another way to fulfill the purpose while enhancing decarbonization. And while we're doing all of that, you'll probably surface items where you think, I just don't know, or we need to do more research on that. When you have that thought, simply highlight it. We want to record that as well, so we can think about the research agenda that we might need as an associated path for this journey. All right, with that said, Jess, take us away into our breakout rooms. Remember, it's rapid. We have 15 minutes and then we'll be back. Welcome back. I hope that you had a robust, quick conversation in your breakout rooms and that your neurons are firing. Now we're going to bring it to the larger conversation. Since you were in your breakout rooms and thinking into the depths of the code, I want to bring us back to the 50,000 foot level for a moment, because I know we'll naturally dig into the details. And so our panelists, the question for you is simply, when it comes to decarbonizing healthcare, do we have the codes that we need? So we have some highlighted here. There's others, even ASHRAE 189.3. You can think of other codes as well. Just broad strokes. Do you think that we have the codes that we need? Is there a gap or something that's missing? I'm going to turn to Kara first, if that's okay. I am putting her on the spot. And by the way, just so you know, the panelists, other than that first question I asked them, do not know what questions are coming at them, nor do I. You will submit many questions that will be interesting, and we'll have a robust conversation. So thank you, panelists, for being part of this. Kara, you get the first word. Kind of thinking broad picture. Do we have the codes that we need?
I think we're working toward it. I think that, like I said, we are being bound by older codes, so that has to change first. Until that changes, there's not a lot we can do. I think we're getting closer. I think, I sit on 189.3. I sit in on the meetings for 90.1. And we represent 170 as well. And we're constantly working toward that. But I would say we're getting closer, but we've got to get the CMS codes changed first.
Great. Panelists, you can just jump in while you're getting ready for that. Tim, do we have the codes that we need? Oh, Tim, you're muted.
Yeah, thanks, Troy. I think we have some limitations on both thought a little bit and probably some of the ventilation standards are handcuffing us significantly. I think one of the things I put on our list for research is, are there heat recovery options in healthcare that we're not considering as part of the codes to mandate recovery of certain aspects of heat? The only thing I know in 190, we really talk a lot about on heat recovery is enthalpy. And I don't know whether we're as efficient as we can be on that, or we need to pursue other opportunities for heat recovery, which would then help us on the reheat.
Excellent. I'm going to call on another couple of panelists, and then we will move on. So Dave Mason, and then Brittany, if you are willing, you have been recruited as a panelist. So I'm going to ask you the same question after that, if you're willing. So Dave, do we have the codes that we need?
Yeah, thanks, Troy. We kind of had a two-part consensus really in our breakout. One is that we should think about having codes focus more on carbon and all the other stuff that we're focusing on is distracting us from carbon. And obviously ventilation rates are a big deal and they're a major impact. The other thing, the second point was that we really should, the low-hanging fruit probably is really with all these existing buildings that we have. We need to address those. So it's good. It's really good input. So that's where we were at. So no, your answer is no, we don't have the codes we need, but I think we've got a good idea going forward. Great.
And Brittany, I apologize in advance for putting you on the spot, but I think you've got it.
Yeah, that's okay. So being part of helping with development of some of the newer standards that we've been working on, like 189.3 and 227, I think that organization of the codes working together and trying to find a process to figure out if we actually need a new standard versus just finding a way to incorporate requirements in the existing standard or figuring out which standard to put it in is something that's really important. So I guess coordination between the standards committees has been something that I think we've been working on, but would be beneficial. For instance, resilience is something that's coming in and that's being prioritized by ASHRAE, but I know that, in 189.1, we have a working group that's working on how do we get resilience into our different sections there, but we don't want to be competing with the way it's done in other standards. We want to be aligning, and we also don't want people to feel like they've got to reference multiple standards to figure out how to make a resilient building. So I don't necessarily know what the answer is and how to fix that, but I do think that it's something that deserves some attention. And I think everything that we've covered here, from reheat to air change rates, heat recovery, those are things that exist, but probably could use some improvement. And again, with the passive design and looking forward to renewable energy and grid harmonization was something else that was discussed in our group.
Great. Brittany, thank you. I'm so glad I called on you. because you give me an excellent segue to a next topic. There's a question in the chat. What is the role of FGI in this discussion? Are other standard setting bodies really where responsibility should lie? And if these other bodies incorporate decarb strategies, how do we make sure that FGI adopts them? That question is really getting at what I'm going to call the ecosystem of codes. And there's a lot of different ways you might imagine this ecosystem could work. And there's ways that the ecosystem works today, right? We have the opportunity now, in some senses, to both deal with the now and with the future, and to envision a greater and better possibility. So I don't want us to restrict ourselves to now and answering these following questions. So FGI has a role in this discussion. FGI, unfortunately, wasn't, Doug wanted to be here, or Dana, who are from FGI, but weren't able to make this time. I did have a very quick conversation with Doug, who is part of FGI, heads FGI, and I left with the impression that FGI thinks that decarbonization is very important and a very principled cause, but that there are other organizations that are codes that are in a much stronger position to make changes, and the FGI is intended to be a baseline for compliance. And if it's perceived as something else than that, then state and federal agencies might not be adopted, and be counterproductive to put things that you might not consider to be minimums in there. And so in some senses, there's this concept that we might be, the FGI rather, might be able to reference the work of other agencies in the appendix. But in some senses, FGI specifically, since doesn't necessarily see decarbonization as their specific role. I know that for FGI because that's the impression I left with after some correspondence with FGI. But I'm sure others representing other codes and standards on this call might say the same thing. Hey, this is really important, but this isn't the role of this particular code. So how, to Brittany's point, how do we imagine that the codes that we have represented here, the 5 breakout rooms that we had, how do those interact? Are there missing parts of the equation? Are there other codes that should be brought in? And how do we get to the point where we have what the decarb movement in some senses calls common but differentiated responsibility? So how do we ensure that everything has a common responsibility, but understand the differentiation and the nuances? Okay, that was a long-winded question, and will be my last long-winded question. I apologize for that, but let's hear from some of our panelists. I'll give you a second to jump in, and then if nobody jumps in, then I'm going to call on Michael Sheeran to start, because I can see him on my screen. But first, let's give our panelists an opportunity to jump in.
Sure. We have the codes we have, and I think an important part of, just as FGI would say, well, it's not our basket, because, just as ASHRAE defines, every code that ASHRAE makes has a title, purpose, and scope. So the question would be, how over the course of time might those title, purpose, and scopes start to align or start to include an element that addresses this topic, perhaps, as opposed to just being tangential to the topic. I saw a little bit of Walt's commentary, and Walt and I were both involved with the latest FGI updates, and as in our 170 breakout session earlier, FGI has a hand in this, whether they realize it or not. And that's not to pick on FGI, because obviously, 170, Jeremy and I, and are offered as early piñatas for tomorrow's Cinco de Mayo festival, because healthcare ventilation, the driver, means fan energy, means reheat, means a lot of things. And it's easy to say, well, just make the numbers lower. There is validity in certain respects, in certain places, in a facility, that we can all reduce the air quantities in places at times, and maybe even beyond that. But until we have adequate amount of information to define that we can do that safely, then yes, you're going to have a lot of foot dragging involved in that process. If there are goals that are beyond one code, but an overlying code that encourages all of these folks and different committees that exist across our nation to be thinking about these things in a more holistic way, then I think that's a very robust goal. I mean, and probably the only way, and maybe, you know, I doubt that that's through CMS, but it's through some way, shape, or form as best we can accomplish it.
Great.
Troy,
Other
I had a
Perfect, go ahead.
response. I think there's, if you would look at the heavy hitters, the three biggest ones would be FGI, 170 and 90.1, because generally those are adopted at the state level, right? And drive some of these occupancies and base building performance. Now, if you would then put a map up of the United States on what states are adopting what codes, you'd see there is a huge delta. So if you said, not only do we want better codes, we also have to get the states to adopt more aggressive codes to support some of this kind of thing. Because if 170 or FGI got reduced ventilation rates, if the states don't adopt it or the feds don't adopt it, it doesn't help us any. We can't apply it in buildings we either own or buildings we're building. So there's that gap out there of how do I not deal with a, say, pre-2010 version of some of these codes at the state level that really don't allow me to effectively attack the decarb strategy.
Excellent. So I see Walt Vernon has his hand raised, and then as a warning, I'm going to call on Bing Liu and then David Eldridge after Walt.
Well, the first observation I would have is this is a really exciting conversation, and I hope this isn't the last time we get this group of thinkers together, because, oh my God, for us to be able to brainstorm together is an opportunity like none I've ever had before. So I hope we do this again. Okay, set that aside. What I was going to say is, Troy mentioned earlier the National Academy of Medicine, and we're working there on this new grand challenge that they're rolling out. And I'm working in particular with Don Berwick, and Don has sort of had this aha moment where, you know, he will say that when he created sort of the definition of healthcare quality, and there's 6 dimensions that were listed in the Crossing the Quality Chasm and the sort of the genesis of IHI, there were 6 dimensions of healthcare quality. And he says, today, it is time for us to expand the understanding of healthcare quality, not only to think about the impact on the patient in front of us, but on our environmental impact beyond us. And so it is time to introduce embodied carbon as a metric of clinical outcomes. And it seems to me that, you know, form follows function, and we're in the architecture, Rob Matthews, engineering world. And, you know, our job, if the people we serve are saying it's time for us to measure ourselves by embodied carbon, surely when we think about the use of ventilation as essentially a medical device, right, for preventing infections, it is time for us to think about embodied carbon as a metric as well. And so I just think there's a huge opportunity to reframe our thinking in how we create these codes.
Excellent. Thank you, Walt. Bing, and then David, and then others.
Thank you, Troy. One of the things to share, I feel like I never met Walt before, but I feel like we can be a best friend in the next several years. As part of ASHRAE's task force on building decarbonization, one of the key issues that we identified, to be honest, as a lawyer, ASHRAE members and the fellow of ASHRAE, we're catching up. We're now leading in many areas. Embodied carbon is one of the areas I think architecture knows a lot compared to mechanical engineer like myself, but we all have a role to play. The first to really understand the full life cycle of construction materials and their impact. And codes can play a role, not necessarily on the energy codes, but most likely maybe on the building codes. We have to benchmark before we regulate their embodied carbon. And there's a group of people actually starting to looking at how to bring the regulation of embodied carbon on the construction materials into the codes, just as we're speaking now. Another part in terms of what the federal is doing is there are going to be quite some infrastructure investment funding to try to create their more low carbon emission cement and steel from the supply chain point of view to helping their address embodied carbon materials, construction materials. I just want to share with you on that one. At our breakout session, there's quite some of the mentioned areas in terms of how look at entirely of the decarbonization of the healthcare. One of the study I recently ran into is for our energy and the carbon emissions for any of the given a building, particularly for large size building like healthcare buildings, 30% was a totally waste of energy averagely. We're not bringing the comfort, etc. It's just totally waste. How we address that, that's kind of low-hanging fruit from codes, from regulation point of view. I don't think there's a clear solution. Only pathway I can see is to move the codes from current, prescribed paths of the codes to outcome-based, which is bring the bridge with the current codes and the building performance standard, which is we try to move to as well. So if we have accountability of the operational carbon reduction and have consequence of that, then we're talking about move the needle. Otherwise, it's still old business as it is, because everything stopped as design and lack of the enforcement after the permit issued it, whatever operation is at the mercy of your facility engineer. So I think that's in terms of cross-reference different code standard regulations, it's a long way to go. But I think there's a successful pathway, what we're currently learning from New York City and Washington State to helping us.
Excellent. David, and then Dick Jackson.
Okay, yeah, in the interest of time, I'll make it pretty quick, and I'll repeat something that I said in our breakout, and that is, in order to address some of these issues, mainly ventilation, we should approach it by building a good deductive argument, right? And sitting where I'm sitting, being on 170, being in Oshpod, the underlying agreement has been basically that more air is better for infection control. Now, this is obviously key in healthcare, right? What we need to do, and I think it's really healthy to question anything like that, anything that's been around a long time like that. And it's been pointed out by many people, we don't have a lot of studies. Even Farhad Mamezadeh said a few years ago in an ASHRAE 170 meeting, we kind of a lack of research supporting that. And therefore, right, and that's the conclusion people come to depending on where they're at. I think that premise needs to be evaluated further. Because what do we have to hang our hats on? We've got Florence Nightingale, right, a nurse in World War I, and we've got Wells Riley, and we have very little research other than that that's associated with it. And one of my colleagues in a healthcare provider here in California is doing all kinds of stuff with hairspray. We all know who that is. And this is good stuff. I mean, this is really good stuff. So my point is that we need to really think about making research a priority for ventilation versus infection control. Because I think where I sit when I hear about reducing carbon, one of the first things I look at is, well, how will this affect patient outcome? How will it affect it, right? In this case, we don't have a lot of information. What we have is telling us, hey, be very careful here. We need to get more research done in this area. So I look forward to helping any way I can with that. That's about all I had. I'm not really necessarily answering you, Troy, very well, but that's what I wanted to cover real quick with the time we've got left.
That's perfect. Thank you, David. So Dick Jackson and then David Eldridge.
I can't resist, David. Florence Nightingale was back in the Crimean War 150 years ago, and I swear most of the things that Florence Nightingale had to say probably make a lot more sense than a lot of us today make with all of our hand waving and rules. I just have to defend my nursing colleagues. A,
yeah, appreciate that.
B, and I don't mean to be snooty about it, but we should genuflect when we say that name, not make fun of it. But where I'm going.
Well, real quick, what I say is the reason why we're still talking about Florence Nightingale is because she was right. If she was wrong, we wouldn't know her name, right? Pretty simple.
Sorry. About 5 years ago, there was this whole idea that copper touch surfaces would reduce transmission of infections, and an entire floor at UCLA Medical Center where I was, the tray tables, the handrails, etc., were changed to carbon. It turned out to be an impossible study because by the time you got through all the layers of regulatory hoops and approvals and all the rest, we really weren't, and all the other complicated factors, it was really very difficult. And yet that kind of real world research is extraordinarily important. And the real world research we depend on a lot of the time is experts going out and finding one more thing is wrong. You put the evaporators next to the air intake or whatever. And so all of our regulatory, not all, so many of the decisions we make are based upon failures in the past. Howie Frumpkin and I have really been pushing very hard for NIH to have a brand new institute dealing with climate and health. And these would be exactly the kind of things that look at. There's about 20 institutes at NIH. It is proposed in the Biden budget that $100 million would go into climate and health. And that's, I'll tell you, NIH could atomize $100 million so fast, you would think it was an atomic bomb. Nothing will change unless there's a full-blown institute with a powerful director that says, this is what we're going to do. And this would be one of the first charges you'd get those 30 young, very brilliant young researchers to start thinking about in a practical way. Because in medicine, what we care about are the outcomes. We have to deal with processes, but it's the outcomes that are the most important, and we're not looking at that.
Thank you, Professor Jackson. David Eldridge, and then Jim Crabb.
So Richard was in our FGI breakout group, and outcomes was definitely the word of the day. So we want more research that can talk about where people are entrenched, with certain values. If we're going to take away from that, they want to know what the trade-off is going to be. So we need to show that there's equivalency. There was a case study mentioned where the code had previously said you could have fewer total air changes if you had more outside air, and then that was changed. And there was some data that seemed to show outcomes were similar between the old facilities and new facilities with that change. But of course, it's hard with all the different variables. But that seemed to be a good indicator of an area to follow up on. And then also outcomes of the energy performance. So I think we need to make sure that if we have a set of prescriptive options, how does it cobble together? There's a lot of interactive effects between different technologies that we're throwing at these buildings. Are we achieving our goals now to reduce energy use of the new buildings, as well as what are we doing to the existing buildings?
Okay, so I'll jump in, assuming that you were going to call on me, Troy. So we're talking about outcomes, and I agree. We've got to somehow connect what we do in our buildings to outcomes. But I want to point out that is research that's going to take time. As you pointed out with the study with copper surfaces, Dick, determining the outcomes that are related to ventilation in healthcare facilities, that's going to be a very difficult thing to figure out, and it's going to take time. And especially if we do it in a really scientific way and have to reproduce the study multiple times. I'm not arguing we shouldn't do that. We should do that, but we can't wait for that to happen before we start to think about different ways of doing things. I am very sympathetic to the ASHRAE 170 committee because the committee has been handed a standard. It happens that standard goes back in some ways to the Hill-Burton Act from, is that the 50s? And so we are basing our hospital ventilation rates on air changes per hour. Well, we know today that air changes per hour is not the right metric for dealing with a pollutant source within a space. That may have something to do with how fast it gets cleaned up after you leave the space, things like that, but it's not directly responsive. And one of the ways we know that is that we have this other group that started from nothing and came up with a ventilation code, and they came up with ASHRAE 62.1 that looks at ventilation related to sources. Now, it started off doing other things, but it's trying to get more and more scientific in that sense. And we need to start thinking, in my opinion, we need to start thinking about looking at hospital ventilation in a similar way. In some cases, it's possible that would increase ventilation rates, but I think more likely it would reduce ventilation rates. There's already evidence that our ventilation rates are higher than they need to be. That's a hard thing to do in the time of COVID, but we do have scientific backing that at least gives us an indication of an indicator that we think will affect outcomes. But it seems to me standing still is not the right answer. And I'll stop there, Troy.
Perfect. Thanks, Jim. Response from our panelists?
I think, Jim, you raise a very good point, which is you can implement change in pieces. One of the earliest pieces, I think partly you addressed in one of the earlier sessions, which is if we are still evaluating what needs to, where you can reduce things, you can still create different sources of the reheat that you are providing to a facility today. Whether it's as Tim Peglow would say, a heat recovery chiller or a solar source or something else as the means to do that, but build those things into a long-term strategy or build those things into the code more sternly. And then with that also gives you the time to to move toward evaluating those things and prioritizing those things, which I think is the same conversation we've been having at 170, even in regards to research, because there are going to be entrenched expectations that things aren't going to change unless there are some good valid, there is clarity around that those things can be changed safely. There's also a history where in instances we have changed things and have found that those changes weren't betterment of the standard. And so there is a conservatism as you jam 50 engineers in a room is likely to happen.
Speaking of jamming 50 people in a room, we've jammed a bunch of people in this room. And for a moment, we put you in breakout rooms to consider specific codes. Were there instances where you said, what I need is for somebody in another room, i.e. a different code, to do something? Are there instances where you were in the room, say on FGI, and the response was, we need ASHRAE 90.1 to do something, or you were in ASHRAE 90.1 and you said we need OSHPD or the California codes to do something. If there were, can you panelists, can you surface those right now so we can discuss?
Try this, Tim. I think one of the things that in the 90.1 that did get some discussion was the 170 issue. Of how can we could drive down overall building consumption and create some new approaches to efficiency if the current standards exist as they do today for both outdoor air and total air changes.
Perfect. Tim, thank you for being our moderator and asking that question to our panel. I see David raised his hand. Go ahead, David. Tim, that was perfect.
Just real quick, I think it became clear in our breakout that in this regulatory environment, working CMS staff into the process could be very, very helpful, if not required, because they hold their purse strings, right? So that's it, though.
Yeah, David, thank you. Other responses to Tim's question or to mine?
I'll suggest something, Troy, and that is, and it's not quite on point, but it's slightly on point. In our group, we talked a lot about, codes, and codes are generally for new buildings. We talked about how codes could be applied to existing buildings in different ways, and that's certainly a thing. We also talked a little bit, in our group, we had both the California Energy Code, which is pushing towards more energy efficiency, and we had the California Building Code, which in some ways is maybe restricting, at least conceptually, what can be done. And those are, potentially in conflict in some ways, as I think Michael Sheeran was, or Tim Peglow was sort of pointing out, right? You have those two aspects to one side's pushing towards more energy, the other person saying, well, here's what's required for safety. And so that need for balance between the two and connection and alignment and finding those sweet spots is really, really going to be important along everywhere. But on the issue of existing buildings, we again mentioned, and I think we talked about that earlier, this idea of and I saw somewhere, I don't know if he's still on here, but Jeff Glass, I know Jeff Glass has been working on the issue of existing buildings up in Washington State. And that's a real bear in terms of how you do that in a mandated way. But I think something around existing buildings is really, really important and difficult and expensive. And we've got to find a way.
Go ahead, Steve.
One of the low-hanging fruits on existing buildings that we probably haven't exercised yet is just knowing what the problem is. So, in San Francisco, every building is required to submit, energy consumption data. So why isn't every building required to submit their carbon, footprint data? You can't manage what you don't know, right? So that would be some low-hanging fruit that I would hope would be relatively uncontroversial. And while it's not the answer, it does start to maybe highlight how we start moving towards answers.
I think one thing to add on incentivizing is giving existing facilities, reasonable performance targets. And, again, I'm going to bring it back to air changes, because what isn't about air changes? If you have an existing hospital, it's, maybe it's running at 6 air changes, maybe it's running at 8, maybe it's constant volume and whatnot. And so it's got some old pneumatic controls and it just is what it is. Retrofitting that to basically be the same thing is not all that compelling. If you were able to tell them, like, no, now you can provide 2 air changes or 3 or whatever that number ends up being, or maybe it's still 6, we don't know one way or the other, that retrofit and being able to turn down lower and get more energy savings and that controls might pay for itself now or get a lot closer. And the business case for making that change could be a lot more attractive if the code lets you go lower. If you're just replacing a 6 air change system with a 6 air change system and you put a better motor on it, that's not gonna, you're not getting anywhere. Not unless there's a bigger incentive somewhere coming from somewhere else. But if you want this to be self-funded, and again, we don't know if those reduced air changes are possible, but if you can give them a real target that says this number is safe, you can go down to that, then the equation changes. But we have to know what that number is first.
Yeah.
Great. Interestingly enough, building on that, you know, we are thinking about codes that are prescribing kind of what we need to do, so number of air changes, et cetera, which is all very important. What if we had a performance-based code? What if we simply said you have to follow the other codes, and a hospital, you need to have an EUI, to use that metric, it might not be the right one, but you need to have an EUI of X, because we recognize that we need to get to 50% by 2030, and if we don't, it affects public health and it affects our patients. What would a code that made that type of prescriptive requirement look like, and do you think it has a role to play? And maybe for that question, we'll start with Bing, and then I saw Michael, you were raising your hand, so we'll go to Michael after that.
Thank you, Troy. You know, this kind of codes already exist in United States. In the city of Boulder, and maybe the first one have for new construction is outcome-based codes. So it's possible, but not so far. It's not a skill. In the current energy code structure, we do have a whole building performance base. It's called Appendix G in 90.1. Title 24 has similar thing. The challenge is it's a simulation based, right? So we all know how wonderful of the whole building simulation, but we also know the constraints. It's not a true outcome based. I think the building performance standards in New York City and Washington State are the true outcome-based standards. It's a mandatory, you have to comply, give the time frame. The challenge is how to bridge the gap. Once you get your new construction, get a permit, right? It's turned into existing building right away. Who foot the bill? Even from your design construction point of view, you meet all the current code requirement, but when you're starting to do the operations, maybe there's a lot of things, you know, the lack of commissionings, you know, the many reasons. Your UI or utility, you know, whatever the target you set up is not meeting the desired target. So I think there's one of the biggest missed piece, not necessarily the codes, is a policy in place or legislation requirement. That would be my thought down here. I can see we possibly move into that direction because many of the European countries already moved to that direction as well. It's true outcome-based codes as well. But it's an economic challenge and the policy challenge we need to solve at a larger scale.
Bing, thank you. Michael?
Yeah, I'm actually going to draft Kara into offering, because I think, you know, the information that ASHI has in working with facilities that are interested in benchmarking their performance and improving their performance over time is a huge resource to all of the facilities. And then maybe there is something where there's a carrot involved, so that, you know, if your energy performance is meeting certain benchmarks, CMS gives you different reimbursement rates. I don't know, but Kara, maybe just a little bit about that side.
Sure, thanks, Michael. I was actually looking for the hand to raise and I wasn't finding it. So yeah, completely agree. And we've looked at some of the standards that are out there that have some of these EUI targets, and we look at what is happening operationally within the healthcare facilities, because we have the data and we can get a good idea throughout all the climate zones what is really happening, and they don't match. And so the danger in setting them to those performance targets is setting fines to them, and there might be a variety of reasons why we can't meet that, or maybe our targets are just too stringent and it's just not going to happen with the technologies that we have. But yeah, we do have that data, and we have looked at that. You know, ASHRAE Standard 100 addresses some of this and that's existing buildings, energy efficiency, and they have targets. But through some different studies, they've recognized that, you know, not just healthcare, but other building types are also affected and are not meeting those targets.
And Tim, we only have a couple of minutes left, Tim, but why don't you go ahead? You'll get the next to final word.
Okay, thanks. I think part of the, from listening and the great conversation, great contributions, I think there are some opportunities. I guess the question is, and I think, Walt, what you're working on is helpful, is what happens if we said, you want carbon emission reductions, we need changes in CMS rules to help us get there. And or we need infrastructure funding to get us there. Because I would agree there's probably still efficiencies we have, but if we can't move CMS on air changes or the like, we're gonna really struggle to get to zero carbon or lower, or to hit the carbon target that they want hit on either existing and or even new. I think is very difficult. Now the question is, I don't think we have enough information to say if we made changes in 170 or we did other things, how would that help us go from a building I would plan to build today, as efficient as I reasonably could with codes, it would potentially consume this level of carbon, to a different level with a different set of guidance that's thoughtful to get there.
Right. Tim, I think that is an important question, and thank you for highlighting it. Today, we've talked about the codes. We've talked about specific codes. We've talked about how they interact. We've talked about conceptually about the process of new codes. And our time is up, but I thank you all for participating in this conversation. I want to leave you with one final question that was in the chat. It simply says, does anyone think we will ever get an agreement on the cost of carbon? I think the question was asked because one way to drive the reductions we're talking about is to put them in code. Another way is to let the market have its way by actually externalizing or internalizing the cost of carbon rather. And so our next workshop is going to be on finance, right? How do we get some of the things that we're talking about financed, and how do we think about finance with the bigger picture? We have an awesome lineup of folks coming. They're signing up. We're going to have a robust conversation with people who have made the carbon transition, and hopefully with people who have thought deeply about what it means to think about this transition broadly across the economy and what it might mean for healthcare. So stay tuned. That workshop will be in 2 weeks. As always, you can continue the conversation from this call on decarb healthcare. In the coming weeks, the conversations on decarb healthcare will be picked up more as we seek to engage you deeply as the workshops off ramp and as this ongoing conversation on ramps. Thank you for being a part of this journey. I encourage you to let your friends and colleagues know about it too. And we'll see you in 2 weeks. Take care, everybody.